welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's project we're going to be making an angle block, a 22.5 degree angle block. I think most of you have seen these sets of angle blocks. They're about $25 a set. Comes with a 1, 2, 3, 4, 5, 10, 15, 20, 25, and 30 degree block. And from that, you can stack and get most any angle you might desire to cut on your vise or holding device on your mill to mill off, except for half degrees or partial degrees. I had a project. The project didn't actually materialize, but what it would have involved, and I may do it later, but what it would have involved would have been making 32 cuts. This is a 45 degree down here, and this is a 45 degree included. So half that is 22.5 degrees, and was not able to get that with any combination of these. So I got on YouTube and got looking around for how to make my own angle block just out of a piece of material for a desired angle. I ran across a video by Stan Zakowski that extremely good solution. What he was using was a swivel base on the vise on his mill, and a little trigonometry, but setting it up with a dial indicator and turning it to the desired angle. Now that is an excellent solution, very viable. The only problem was once you set up for that, you need to do all your pieces at that time, because if you take it down, you'll have to go through the whole setup again. So I got to looking a little bit further, and I found a video by Joe Pazinski, Joe Pie as he's known by a lot of his viewers, where he was actually making an angle block. I think he was making a 20 degree one. I'm not sure, but he showed an excellent solution. And that solution, he drew it on his board as Joe does most of the time, drew it on his whiteboard, then went over to the lathe, went over to the mill and cut it out. And in reading the comments on that video, seemed a few folks had a few questions, and I don't think that I can explain it any better than Joe did. However, I think it's a worthwhile enough solution to repeat what he did, and in my case for 22.5 degrees. About the only thing you will need to do that, you'll need a couple of precision, drill rod, gauge pins. You need 2 the same size. You need a reamer, chucking reamer, something like this, that you can make a hole that these will fit in properly. Now, I've got gauge pin sets, but I don't have duplicates. And as I said, you need 2 the same size. Well, several years ago, a friend of mine pointed out to me that old printers, copiers, fax machines, any of that type of equipment that has rollers in it, primarily to move paper, is an excellent source for drill rod. Some of them will be metric sizes, some of them will be imperial. As it turns out, what I've got here, a good portion of them are, let's see, what was that, 5/16, 0.3125. And I have a chucking reamer for that size. So I'm going to turn the camera around onto my little drawing I've done here and show you what we're going to be working with, the piece that we'll be working with. All right, let's see if I can explain this as well as Joe did. and maybe using a little bit different terms. Again, I don't expect to be able to do any better explanation than what Joe did. It's just going to be a little different explanation, and you know, hopefully it'll help somebody. But again, this solution is worth repeating. The outside that I've got drawn to scale here is actually my piece of material. It's about 2¼ inches. No, I'm sorry, overall length is 3.192 by 1.962. In other words, it started out as a 2-inch wide piece that I just milled off the roll from the foreman roll. Got it squared up. I'm satisfied I've got a square on this edge. We want a 22.5 degree line in that. Now I could try to set it up with my protractor and scribe a line across there, but we're looking precision here. So there's a better way to do that. For sanity's sake, I'm going to draw a line on my material just for reference sake. But what we're going to do is use a little bit of trigonometry to figure out where to drill a couple holes in this piece. Joe and Stan both used a trigonometry, a sine table or a trig table from various different sources. They'll give you normally whole degrees. We're looking fractional degree here, and you could take the difference between 22 degrees and 23 degrees and split that difference in half and add it to the 22 degree. But what we want to find is the tangent of 22.5 degrees. Remember, this outside here is our workpiece, but we're going to develop an imaginary triangle on the inside in here. So at some point over here, approximately 0.6 inches from this edge and approximately 0.3 inches from that edge, I'm going to put a hole that one of these pins will fit in. And I'm going to put another hole up here. And those holes are going to rest on the vice jaw on the mill, and then we can mill this edge off. But to know where to put this hole, we need to know a little bit about that angle. We need to know what the tangent of 22.5 degrees is. Now, again, you can go to your tangent charts in the back of your machinery handbook or your old trig book from high school or wherever. You can simply go to the web and go to Google and say, or ask for the tangent of 22.5 degrees. Be sure you tell Google degrees. If not, it'll give you the tangent of 22.5 radians. But as I've showed in some other videos, this is the 21st century. You're watching this, good chance you've got a smart device in your pocket. So let's try this. Get the volume turned up on it. What is the tangent of 22.5 degrees?
The answer is approximately 0.4142.
All right, 0.4142 is the tangent of 22.5 degrees. Now, on my piece of material here, I've determined that I can stay in the clear about 2.25 inches over here. This value doesn't matter. Remember, we're on a plane here. It doesn't, for infinity out here, this angle will be the same. So let's ask Siri again what 2.25 times that tangent it just told us. What is 0.4142 times 2.25.
It's about 0.9319.
All right, 0.9319. We're going to round that off to 0.932. That's all the math that's necessary. So we're going to put a hole over here. We're just going to pick a position and put a hole over here. On the DRO, we're going to zero it out. Then we're going to move 2.25 inches on the x-axis. And on the y-axis, we're going to move that value it just told us, which is 0.932 up here. Drill a hole at that point. This is where our 2 pins will go. So I'm going to turn to the mill and get this set up, and then I'll bring you back. I've got the workpiece in the mill vise now, and the piece I'm using is 3/16 thick. If I'd had any 1/4 inch material here, I would have definitely used that. And if that project I was talking about ever does develop, I may go back and remake this with a piece of 1/4 inch thick stock. This should be fine though for demonstration purposes. And this edge here and this edge is going to be our finish. I actually did set an angle block up on the on my granite stone and stoned off this bottom edge flat and this end down here flat. They were flat from the milling, but that just dressed up the finish on that. Now again, the position of this first hole does not really matter as long as you've done a little preliminary check and you're sure you've got room for clearance for your other hole. So where I'm at right now, I've got the table locked down. I'm going to zero out the X and Y axis on the DRO. I'm assuming y'all just take my word for that. I'm not going to try to put the camera on the DRO and show you all that. And remember I said my drill pins or my gauge pins were 5/16 drill rod, 0.3125. So I'm using a 1964 drill. That is a 64th less than 5/16. So I'll use that to drill with, and then we'll ream out to our desired finish size. Now that will likely need a little bit of deburring. I know it will on the bottom side. But our gauge pin is a very, very snug fit in there. Good fit. So on the DRO, remember we said across this x-axis, we were going to go with 2.25. That's just what fit on this piece of material here. It could be whatever will fit on your material and will fit across your vise jaws. So we're going to go 2.25 exactly. All right. Now we're going to repeat this process, or I'm sorry, we're not going to drill here. We've come over that distance. Now, we asked Siri what the tangent of 22.5 degrees, which is what we want our block to be. She told us that was 0.4142. We multiplied that times that distance on the x-axis here, 2.25. That told us that our distance to travel up on the y was 0.932. So on the y-axis, and there's our 0.932. All right, let's put our center drill back in. The mill table is locked down on both axes. Joe made a very good point too. If you don't have drill rod laying around or you don't have gauge pins to use, he suggested using a couple of end mills. Maybe a 1/4 inch, well, whatever your shaft size here, find two that's the same size, you know, probably a 1/4 inch, 5/16, something to that effect. You will likely have something in your shop you can do this with. The only thing you might be missing is the reamer. And a set of chucking reamers are not that expensive either. All right, there's our 2 holes drilled. And again, I drew me a line there just for sanity check later. I'm going to carry this over to the drill press, and where I've got a countersink tool over there, and just clean these burrs up a little bit and be right back. I've brought the camera around to the front of the mill now and got it zoomed in pretty close on the indicator. For this project to work, your vise jaw needs to be perpendicular to your spindle. In other words, it needs to be flat with the table. And your front jaw, your movable jaw, does not need to stick up, can't stick up any above the back jaw. If it does, you need to clean out from under it, whatever. But I've got the indicator set on there. What we're going to do is take this workpiece that I've put the 2 pins in, and we're going to index it on that back jaw. Clamp it down tight. And then we're going to mill off this excess up here. But again, we want to be absolutely certain that that is level. We've got about a 2.5 inch span in the middle in there that we'll be using. Right at the very end of my jaw down here, it's about a 1/2 thousandths higher right at this end. But this section in here is what we're going to be using, and I'm satisfied that that is level and perpendicular to our spindle. So I'm going to get the end mill set back up, or set up in the mill, and get the camera back in position. I've got the 2 pins installed in the holes that we drilled, and we know these pins, because of the trigonometry that we used, we know these pins are exactly 22.5 degrees, or set at a 22.5 degree angle. So if we set that on our vise jaws, good and secure, tighten that down good and tight. All right. So now we're just going to keep working this down. I'm going to leave about a 1/2 inch on the low side here, maybe 3/8, just somewhere around this point right here. All right, I'll bring you back when we get a little closer to our desired depth. Okay, I think about one more small pass. We'll get that about where we want it. All right, let's see what we got. Remove our gauge pins. Now we have a 22.5 degree angle block. You can do this, make your own set of angle blocks if you like, for any size you want. I'll take my stamps and stamp 22.5 degrees on that. Okay, I've got our 22.5 stamped on the angle block now. It can go right along with the rest of my angle blocks. But if you recall our project over here, what I originally set out to do, and don't let this confuse you now, my project and making the angle block are somewhat different. I needed this angle block to do the project, but to get this desired angle right here, I can't just set a piece of material on the angle block on the vise and mill that off. If I do, I'm going to wind up with an angle such as this. And if you put two of those together, you wind up with a beautiful 45-degree acute angle. But that's not what I was looking for on my project. On my project, I'm looking at an obtuse angle, greater than 90 degrees. This is a 45-degree angle, acute, less than 90 degrees. I want it back in this direction. So I want the complement of 22.5, which is 67.5. I can go back to my set of angle blocks. I can take the 30-degree block, take the 15-degree, that gives me 45. The 22.5, that gives me 67.5. I simply set those up on a parallel I had in the bottom of my vise. Set them up just like that. Put my workpiece in and come up with the desired angle there. Do that on two workpieces and I have exactly what I was looking for. 45 obtuse angle, greater than 90 degrees, or the complement of it in that direction. So again, don't let my project confuse you with what we're doing here. What we're doing here is just making a simple angle block using a little bit of trigonometry. We put a hole over here. We knew what angle we wanted, so we asked Siri, or we looked on Google, or we looked in trig tables, whatever, and we got the tangent of our desired angle. In our case, it was 22.5, and we got the tangent of that. Then we multiplied that times the distance that we said we were going to use across this x-axis down here, and that gave us what this side of our right triangle would be. Very, very simple trigonometry. I hope you get a little bit out of this. I appreciate Stan and Joe's videos. They led me to this. I'm sure I will make several more blocks. And if that project that I spoke of earlier ever comes into fruition, what I'll do is simply do same math and make a 67.5 degree instead of having to stack all those up. Again, take care, and we'll see you on the next video. Oh, and don't forget, old printers, copiers, fax machines, all that kind of stuff is an excellent source for drill rod.